or Q, then P. Do we know the order of operations? Yeah, we work inside the bracket, we do this, we do the not C, and the last thing we do is the or. So the order of operations is clear, so it is a well-formed formula. Last operation we would perform would be the or, so we would say the main logical operator is or. Everybody got that? Okay, 6. 6 is not Z or Q, then P. Do we know the order of operations? Well, yeah, we do the not Z, then we would do inside the brackets, and then we would do that. So it is a well-formed formula. Main logical operator is the last one we perform, so conditional. Okay. Let me skip to 8. Okay, 8 has bracket not C or Q, then P. What about this? Well-formed or not? Do we know the order of operations? Well, there's some brackets around this Q, but it's just around the Q. It doesn't tell us what the Q belongs to the not Z or the P. Does everybody understand that? So this one is ambiguous, so it is not a well-formed formula, and therefore the main logical operator, there is none. Okay, so let's look at 9. 9 is the same thing, but we have parentheses located in different places. Now it's clear. We would do this, then we would do that, and then we would do the or. So it is clear, so it's a well-formed formula, and the main operator is the operation we would do last, and so that would be the or would be the main logical operator. Okay? 10. Just take a look at 10 in your book. We have Z, not, or. That makes no sense, right? That's like saying 4 plus times 7, okay? You have two operators right next to each other. No good, okay? 11, not Z, then not P or Q. Is order operations clear here? Yes, we would do this, then we would negate it, we would negate this, and the last thing we would do is this, so we know the order of operations, so it's a well-formed formula, and what? The last operation would be the conditional, so that's the main logical operator. Okay. 12, everybody can look at 12 and see that it's not a well-formed formula because there's an operator with nothing to the left of it and there needs to be something. 13, this one is important, H and P, or V if and only if F, then Z. Well-formed formula or not? Anybody? Well, we would know we would work inside the brackets, but then what? We don't know if we're supposed to do this or operation first, or if we're supposed to do this if-then operation. We don't know whether the V, if and only if P belongs to this, or if it belongs to the Z. Does everybody understand that? So it's logically ambiguous, so we say it is not a well-formed formula, and therefore we don't even talk about what the main logical operator is. Okay? So now this one, you might say, hey, this one, it's easy to spot the main logical operator, this negation out there, and so we negate all that stuff, that's the last thing that we would do, right? And so you might say it's well-formed, negation is the main logical operator. But look, this one, 14, is the same as 13, except for it just says negation outside of the whole thing. So this part inside these big brackets is logically ambiguous. Does everybody understand that? So we don't know where that belongs. So this is not a well-formed formula. Even though it looks like not well-formed formula, even though it looks like it's easy to identify the main logical operator, but that's not a main logical operator because we don't know what's going on in there. Okay, so 15. Not, oh, this is big. H and P or B only F then Z okay. Is there a clear order of operations here? Yeah, we go innermost brackets outward here, and then we would do this operation. We'd have to do this, and then we do this operation, and then we would negate it all. So this is a well-formed formula, and the main logical operator is the negation. So it's just this, we took this one, and then we added in brackets to tell us that the V, if and only if F goes with the then Z part, as opposed to the H and P part. Everybody understand that? Okay, so that's 15, that was clear. 16, it should be clear that this makes no sense whatsoever. We have G, then, if and only if P or B. No, you can't stack up operators. Does everybody understand that? Well, not one operator for another. The only exception is if it involves negation. Okay. And then 17, well gosh, 17, there's a G, K, and there's no operator in there, so 17 is not a well-formed formula either. Okay. 19 is a well-formed formula. The main logical operator would be the OR. Okay. On 19, it would be the OR. On 20, the main logical operator would be the first negation. Does everybody understand that? Because you have to, on 20, you have to do everything inside the brackets and then negate that result. Okay. All right. So let me turn to 2.5. Okay. And in 2.5, what we're doing is we're supposing that someone has been translating ordinary English into symbolic notation, and they've done one step of that. They've taken the sentence and they put in statement constants, and they've left all of the other verbiage, all the logical operators intact, and we just have to do the last step. So on number 1, we have X or Y or Z. Okay. Now, if I just put in the symbols for or, I get X or Y or Z. But we have a problem. Is this a well-formed formula? It is not. Okay. Can we make it one? We can. We can do this, X or Y or Z. That would make it a well-formed formula. And also we could have done this, X or Y or Z. That would make it a well-formed formula, okay? And what I'm gonna say is this, if you have a string of, notice that these are all disjunctions. If you have a string of disjunctions, you can put in parentheses arbitrarily to make it a well-formed formula. Does everybody understand that? You can do that for conjunctions, disjunctions, and biconditionals. So if you have A and B and C, you can add in parentheses. Or if you have A or B or C, you can add in. Or if you have A, if and only if B, if and only if C, you can add them in either one of these two ways arbitrarily. And you must add them in to make it clear, a well-formed formula. Does everybody understand that? You cannot do it if you have a mixture of ands or ors or if-thens or if and only ifs. Does everybody understand? If there's a mixture of types, no can do. Okay, so number one, we have to either write this or this. That would be wrong. The first one would be wrong. Okay, number two, we have this very same thing, x or comma y or z. The only difference is we've got a punctuation mark paired with an operator. Boom. And that tells us something. That tells us that that or is the main logical operator. Okay? So I'm going to put the or down, and that means everything to the left of this is one disjunct. Okay? And everything to the right is one disjunct. So over here it's only x, and over here it's y or z. Okay? Do I have extra parentheses? Yes. I could have written it like this, x or y or z. Does everybody see this? So the operator paired with the punctuation mark tells us that's the main operator, and that's why I put up these parentheses to make sure that this or was the last operation performed. Okay? So